Hello, everyone. Today we are going to look at what degrees of freedom is. Imagine you trying to pick up a cup of coffee. You reach forward, you lift your arm, you rotate your wrist, and you pick up the cup. Each of these is a separate independent movement. In robotics, the total number of independent movements a system can make is called degrees of freedom, also denoted by DOF. Today, we will talk about what that means and how robotics is calculated without going into a lot of maths. So, what does degree of freedom really mean? At its simplest, a degree of freedom is one independent way a robot can move. If a robot can move only in one independent way, it has one degree of freedom. If it can move in multiple independent ways, each one adds another degree of freedom. This idea applies to robots, humans, mechanical systems, basically anything that moves. Let's look at the human body to understand this better. Your body already gives you a perfect way to learn about this. For example, your arm can move in different directions at the shoulder, bend at the elbow, rotate and tilt at the wrist. Each independent motion adds to total degrees of freedom of your arm. That's why the human movement feels so flexible and why building robots like humans is so hard. Let's get into what this means for robotics. When you hear someone say 6 degrees of freedom for a robot arm, it means that the arm has 6 independent movements it can control. And that usually comes from the 6 joints. Each joint contributes motion, but only if that motion is independent of the others. In robotics, degrees of freedoms are not guessed or they are not loosely defined. Engineers use a well-known industry formula called as Grübler's formula. Now, you don't need to know the equation, but it's important to know what it really accounts for. At a very high level, this formula considers the number of rigid links in the system, the number of joints connecting those links, and the number of joints used, such as rotational or sliding, as well as the constraints those joints impose on the movement. The formula's job is to determine how many independent motions remain once all these constraints are applied. The final number is actually the robot's degree of freedom. Well, why the formula exists at all? The reason this formula really matters is that real robots are not just a collection of joints. Some joints limit movement, constrain other joints, or reduce the overall flexibility. The formula ensures that engineers precisely understand what motions are physically possible, what motions are impossible, and how complex the robot will be in order to control it. Even though the math formula is formal, the idea behind it is simple. Count what can move independently after all the constraints are applied. Okay, let's move on. A common misconception is that higher degrees of freedom automatically mean a better robot. But in reality, more degrees of freedom mean more hardware. They also mean more control complexity and more difficulty for planning and as well as AI. That's why simple robots have low degrees of freedom. Industrial arms usually settle around 6. The humanoids and surgical robots go higher when precision actually demands that. The right number of degrees of freedom really depends entirely on the task. Moving on, why do degrees of freedom really matter in robotics and AI? Degrees of freedom is important on how flexible robots motion could be, because each additional degree of freedom give the robot another independent way to position or orient itself in real world. How human like it can appear, because human movement relies on many degrees of freedom and robots need a similar number to replicate natural fluid motion. How hard it is for algorithms to control or learn movement, because every added degree of freedom dramatically increases the number of possible motions the algorithm must evaluate and coordinate. High degree of freedom robots are powerful, but they are also extremely hard to build and control, as they offer great capability and precision, but at the cost of exponential increases in control, planning, and learning complexity. So, when you hear degrees of freedom, next time, don't think of equations. Think of how many independent ways can this system really move once all the constraints are applied. Thank you so much for watching this video. If you really found this helpful, please like and subscribe. Also, drop a comment on what more topics would you like to dive deeper into. And until next time, keep exploring the amazing world of robotics.